Hey guys, today we are doing chapter 25 notes. You will be happy to know that this is our last instructional video. Since they cut our course short, this will be the last new thing you have to learn. So after this week, we will be in review. Our last unit is on matched pairs testing. So, matched pairs, it looks like a two-sample mean test, but they are not independent. So remember, your first condition says that your two groups are random and independent. In a matched pairs test, they will not be independent because remember, matched pairs from a long time ago is when you test the same group twice. So for example, a student's taking a pre-test and a post-test. They are not independent of each other because both students are taking, the students are taking both tests. I think the example we did in class was with dancers. If you did the dancers did one exercise and then they did another exercise and they compared those two exercises with the same dancers. So matched pairs test is not independent, so it's going to be a little bit different. So we're still doing a t-test, which means we're still doing stat test 2 for the p-value and stat test 8 for the confidence interval. But your null and alternate are different this time. So if you see here, it says your null will always be d equals 0. D stands for difference, the difference between your two tests. For these, you're going to put your first set of data in L1 and your second set of data in L2, but we're actually going to run all the calculations using L3. L3 is going to be L1 minus L2. So I'll show you what that looks like in an example. So your null will be, there is no difference between them, so L3 is basically 0, and your alternate will be that there is some sort of difference. Your standard error formula, I'm sorry that's in black and kind of hard to see, but it is the exact same formula we've been using for sample means, which is standard deviation over square root of n. So here's the example we're going to do. It says, in many countries, husbands tend to be slightly older than their wives. The given data has been taken from a random sample of 16 British couples to estimate the mean difference of husbands and wives' ages among British couples. Is there sufficient evidence that husbands in Britain are on average older than their wives? If so, how much older? So you're going to want to put the wives in L1 and the husbands in L2. I've already done this just to save a bit of time, but for you, you may want to pause the video so you can get that in. So wives in L1, husbands in L2. In L3, I'm going to do the difference between L1 and L2. So scroll up, put the black bar on L3, and if you hit second 1, it'll bring up L1, minus second 2 will bring up L2, and hit enter, and it will populate L3 for you with the difference of L1 and L2. So this is the column we're going to be using to solve all of these. All right, so we entered our data into L1 and L2. We want to state our hypothesis. So coming over here, dropping pins. Your null every single time, no matter what, will be the difference is 0. Remember, it matters whether you use P, M, or D. The alternate, in this case, we are doing, let's see, L1 minus L2 to get L3, and this was wives minus husbands. Now, if we think that husbands are older than wives, that means we are doing a small number minus a large number. When I do a small number minus a large number, I get a negative number. That means this is less than 0. Okay, it does not actually matter which way you go, L1 or L2. You can go whichever way you want, but pay attention, think it through, like take a moment and really think it through as if your answer here, if you expect it to be positive or negative. If you expect it to be positive, it's greater than 0. If you expect it to be negative, it's less than 0. So if I do a little number minus a big number, because I expect them to be older, I would get a negative number. All right, conditions are already on the screen, so I'm not going to write those, but you need to write them down. Your conditions are the same, except we still want a random sample, but this time you would not say it is random and independent. We want it to be matched pairs. The whole reason we're going over this is because they are not independent. So you would say random sample and it's matched pairs. The other two are the same. Your population still has to be 10 times your sample size, so 160 couples. And you still need a sample of at least 40. In this case, we do not have a sample of 40. Our sample is less than 40, so you would look at a histogram of L3. Not a histogram of L1 and L2 combined, a histogram of L3. You want it to be unimodal and symmetric. So make sure you write all 4 of those down. They have to be there, written by you. All right, so now we're going to find some information. We're going to do the test. I'm going to go ahead and calculate a couple things just because it may ask you later. So standard error in this. I would need my standard deviation from running one variable statistics. Or actually, I think it tells you when you run stat test 2. Let's see real quick. So, if you wanted to see how to do that. So let's go second, stat plot. Make sure your plot is on when you go to histogram. And remember, make sure you change that to L3. So quick zoom 9. Oops, maybe you're hitting extra buttons. Zoom 9. We'll show you that histogram. Okay. So I'm going to go stat test 2. Now, this time it gave me data. I had to put the data in. So my null is that there is no difference. That's 0. I am using list 3. Make sure you change it to list 3. And I believe we're using less than down to calculate. Yes, it does. So this gives you your t-score, p-value, your mean, and standard deviation, and your sample size. So when you run this, it gives you pretty much everything you could ever need. So standard error would be my standard deviation, which is 4.8 over the square root of 16. When I put that in the calculator, you should get 1.209. T-score. And guys, on your test, remember, it doesn't walk you through all the steps how I do on your classwork. Like, hey, state this, state this, state this, state this. I do that so you get in the habit of stating all of that stuff. On your final exam, it's not going to tell you to state anything. It is just going to give you this situation right here on the PowerPoint, and then expect you to write all of that stuff. It's not going to say, hey, list the null and alternate. Hey, list the conditions. Hey, list your standard error, t-score, p-value, list the conclusion. It is not going to have any of those things there. It is going to expect you to know to do that. Just a heads up. So that's why I'm going through all these things, because you need to practice going through all of these things, because it's not going to tell you to. All right, t-score, getting out of the calculator, is negative 1.86. P-value is 0.041. So, our conclusion here, which it's not going to ask you for, but expect you to write anyway. Based on our data, we reject the null hypothesis because our p-value of 0.041 is less than 0.05. Therefore, y'all should be really good at writing these by now. We cannot conclude, that wives are younger than their husband. Now, let's say you did that with a confidence interval instead. Still the same thing, stat test, I believe it's 8. Yep, T interval. I'm still using data. I'm still using L3. I'm going to do a 95% confidence level because it didn't tell me which one to use. And there's my confidence interval. So that is negative 4.828 and 0.327. So we would write we are 95% confident that the difference, make sure you say difference here. Remember, if you're talking about sample proportion, you would say true proportion. If you're talking about mean, you would say true mean. Here, we're talking about difference. You can even say true difference if you want, but I'm just going to stick with difference in ages between wives and husbands is negative 4.828 to 0.327 years. since 0 is contained in this interval, we cannot conclude that wives are younger. So the only thing to be mindful of here is this, when you at first look at it, it looks like a 2-sample t-test. It's not a 2-sample. You're not comparing men and women separately. You are comparing the difference in their ages, which makes it a 1-sample. So that's the only thing to be mindful of, is these can get a little tricky. So when you are going through your conditions, when you notice that, hey, this is random, but they are not independent, that should be, hey, I am not doing a 2-sample t-test. I am now doing a matched pairs. So just something to be careful of. All right, well, this is everything I've got for you guys this semester. We will definitely be reviewing, but if you have any questions, please feel free to email me, and I'll talk to you guys later.